So welcome back. We're going to continue on from the previous video when we're making our WPF object-oriented media player. But we also want to learn a little bit more about advanced subjects in object orientation. In this one, we're going to be talking about generics and collections. And we're just going to touch on the surface on how to use generics. The best way to do this is by us doing it in the code. And actually, we're also going to have some visuals as well to make it much easier. But first and foremost, let's go ahead and start Visual Studio 2022, and I'm going to hit Create New Project. I'm going to make a WPF project since that's where we're actually going to be using it when we continue on. Right now, this is just going to, this part is going to give us a clearer understanding of generics before we actually use generics. So here I'm going to go C#, Windows, Desktop, and I'm going to choose a WPF application here. But I can see right here that says C#, Windows, and Desktop, whereas what I'm going to want is down here where it says C#, XAML, Windows, and Desktop. So I'm going to click on that and go next. I'm going to give it a name, but this is basically a test of ours, so we're going to say generic test. You can store that wherever you want. Everything else remains the same. Place solution and project in the same directory. Then I can go ahead and hit create. So here we are in our WPF project that we just created. Let's first put things into context regarding generics. And by looking at this image here, and actually, let's put it into further context by looking at the definition of generics. Let me just make this here. So here's the Microsoft definition of generics. Generics are code templates that you can define and reuse throughout your code base. They provide a way to tell functions, classes, and interfaces what type you want to use when you call it. So that's the official definition of generics. And an overview of that, or an illustration of that, is this generated image right here, where you have integers, you have strings, you have doubles, all these different types. Instead of them going to individual functions, so normally each one of these, this would be a function. So I would need a function for each one of these types to make a list or to do the very exact same thing that I want to do on one. I want to do on all of them, but all these functions would make me duplicate the same code to do the same thing on each individual one. So instead of doing this, what we do is we remove all of this redundancy and we just make one class here or one function here that does all of that regardless of the type that goes in, and T stands for type. So one type goes in and it expects whatever type that you define it as when you're declaring this function, and it will go ahead and do the same thing for each one that you bring in for type T. So you can make generics, you can make generic functions, you can make generic classes. So I can have a generic class. I can make generic interfaces, methods, these sort of things. So I can go on and on and on with these generics, and it's very useful, and it prevents you from actually having a lot of redundant code for different types. So let's take a quick look at a code example of this. So here we are inside of our WPF application. What I want to do, though, is I want to create a new class. Now, I can create a class directly in here, but I can also go here on the generic test, right-click, go add, and then all the way here, I can say class. I'm just going to change this internal to public. And inside of here, I'm going to put my notes as to what I want to do. So and then I'm going to want a method to create an array of strings. And then how about double? So we'll have one that creates double. So let's start here by creating this method that creates strings. So just so you can get the idea here. So I'm going to say public int So let's look at the second part for the strings. And then let's look at this other part for the double. Now, before I do the double, I just want to see these work here. So create a string array. This is create an integer array. So we're going to go ahead and go to the main class. I'm going to first save this, and I'm going to go to the main class here, and I'm going to use that here so we can see actually that this works. So when we do our generic, we can see that that works as well. So inside of here, I'm going to first create an instance of the array creator. And so when my application starts, underneath the initialize component, I'm going to go ahead and create an instance of that array. This is my note, actually, my comment. All right, so now I have one of these ready to go. So now I want to use the array, the array creator. I want to use that to make an array of integers. So right here I have an array, and it's an array of integers. Here's the name of my array, int array, and that equals array creator dot create int arrays. So if I were to drag my array creator over here to the right, we can see inside of my array creator, inside of the int, I have this create array and this create array. So I'm giving it a 1 and I'm giving a 2 here. And that's going to be the first element and then the second element. And it's going to return an array of those two elements. And it's going to put it right here in this variable here, which is also an array. Okay. Now I'm going to print out to the console int array, and I'm going to have that element, and then I'm going to have this element here. So when I run this, I'm going to want the output available. So here's my output here. You can see in my output, somewhere in my output, you see int array colon 1 2. So that's what was printed out. If you wanted to print out on the front on your interface, instead of us using the console write line, what we can do is we can go to our UI. We can create a label, drag that here. I'm going to name this label. So I'm going to go over here to the properties. And I'm going to name that LBL message. I don't need to change anything because we're just doing this as a test. I'm going to hit Control S to save. Go back here in my code behind. And instead of console write line, I'm going to say LBL message dot content. And that content is going to equal everything that's inside of this. Okay, so I can play that. And there you have it right here, the output of that array. Okay, so let's try the same thing for the string. All right, so we have this, we're creating one for the string. So here we are, here's our variable, and it's an array of strings. So we have an array of strings, here's the name of it, and now we're going to go ahead and call our array creator, the one that we made up here. So we're going inside of this class, and then we're going to call that create string function right here. And what it's going to do is going to take hello and world and create an array of that, and then we're going to print that out again. Now you can go ahead and test out your console.write line, but what I'm going to do is I'm going to just run it inside of my LBL content instead, so I can see it on the interface. Now, what's going to happen is this is going to run, and then this is going to run. So for this not to run, I'm just going to comment that out. Control S to save that, and then I'm going to run it. And there we have it. We have string array colon hello world. So we have an array that has hello and world. And how do we do that? Well, we had to create two different functions. So let's say if I wanted to do the double, it's going to be the same thing. So this will be the code for the double. You can see, really, it's the same thing, except I have to keep adding different types here in order for it to work. So all of this is going to be the same, and this is going to be the same. It's just I have to do this if I want to do different types. So over here, since I put this here, I have to Control S to save that. But if I go further down here and I added the double, okay, so this would also work. And now I have my double. So I have 1.1, 2.2 going in there. And then I'm going to print this out to the console. And again, if you don't want it printed out to the console and you want it to your label, you can do that same thing and just comment this out. And if I needed more, I have to keep on creating different arrays, different types in here, going back and forth. So I'm going to run this just to make sure it works. And there it does. However, as we can see here, I'm duplicating code. So what if I want a type? What if I wanted to create an array of characters or array of tools or array of items or whatever it might be? I'm going to have to keep on creating different functions to do exactly this one line. So now we see one really good use that we have for generics. Instead of doing all of this, we can simply create a generic to do that for us. So how would we replace all of this with a generic? Very simple. First of all, let me remove all of this. And I'm going to put my little comment here. Okay. And now I'm going to write my generic function. And it's going to be an array. So of array, it's going to be an array of type T. And save that. So the thing I need to change over here, because we had all those different types before, all those different functions before, we just need to change it to the one function that's over here. So we'll go here, here, here. So now you see we're doing different types here, but yet we're not getting an error, and it's all using one function. So if I were to undo this and run it, see, it works just the same. Let's try the other ones just to be sure. That's the strings. And the doubles. As we can see here, we took the create array method and we converted it to, well, we just made a generic type, a generic method, not a generic type. We made a generic method, and that generic method automatically adapts to the type of argument that we pass to it. And we can thank the inference provided by C# compiler. It also creates an array of appropriate types, right? Our method here. No matter what type we pass in, it creates an array of appropriate types. So whether it's integers, doubles, strings, it creates an array. So this single method replaces all of those other methods and all those other definitions that we were required to have before we were using generics. And this illustrates the power and flexibility of generics, generic methods, at least inside of C#. Now, there's other kinds of generics that we could use, but this one is solely focused on generic methods. We can even create generic classes, which is what we're going to do when we continue on with our media player. This quick introduction to generics gives us some context that we could use. So when we move on now to actually applying this to our media creator or our media player, we know what we're doing. At least we have an understanding of what we're doing when we're using the generics inside of our media player application. So let's go ahead and move on to the media player and add this knowledge onto our working project.